Welcome back, engineers. In our last videos, we cracked open the real power behind nested endpoints and query parameters in RESTful APIs. We explored how to design clean URL structures, enforce access control with real Java code, and dynamically filter child resources with query parameters, just like top engineers do it in production. Today, we level up. We're going to walk through real-time practical scenarios from companies like Airbnb, Pinterest, and Slack, and wrap up with a powerful concept every high-scale app needs: rate limiting, like the kind used in apps at Twitter scale. By the end of this video, you'll not just understand the what, you'll see the how behind API design that scales, secures, and simplifies. So, we're going to start with Airbnb. Let's say you're a user checking your upcoming stays. When Airbnb loads your booking history, it doesn't just blast the server with all the bookings you've ever made. Instead, it smartly uses query parameters to filter the response. Here's what that might look like. This call tells the backend, give me only the upcoming bookings for user 345, where the check-in date is after June 1st, 2024. That's the power of query parameters. They allow real-time dynamic filtering based on user context. They reduce payload, improve performance, and scale beautifully. And this is exactly how companies like Airbnb provide a smooth, fast experience, even when dealing with millions of users and bookings. Now let's go deeper with two advanced backend questions inspired by this exact scenario. How would you implement pagination for this bookings API to handle large data sets efficiently? Imagine a power user who's made 200 bookings. Loading all of those in one response would be a nightmare for both the front end and the database. To solve this, we use cursor pagination, which is much more reliable at scale than offset-based methods. Here's how we do it in Node.js with Express. Here, the cursor tells the database where to resume the next page of results. It avoids common pitfalls like missing or duplicated entries when data changes mid-pagination. It's fast, it's scalable, and it's production-ready, exactly what high-traffic apps like Airbnb need. How can you secure this endpoint to prevent unauthorized access to booking data? This is where JWT authentication comes in. In production systems, it's critical that users only access their own data, especially when endpoints are designed with dynamic parameters like /users:/ID bookings. Here's how you protect it. JWT lets the backend validate identity at every request. No token, no access. Wrong token, access denied. This kind of security mechanism is non-negotiable in any real-world app where user data privacy is paramount, and Airbnb gets it right. In today's job market, surface-level answers aren't enough. Interviewers expect you to go beyond theory and show real-world understanding, like how to paginate large datasets or secure endpoints with JWT. It's not just about writing code, it's about solving problems at scale, like Airbnb does. Certifications can get your resume noticed, but it's your ability to think deeply, implement smart solutions, and communicate them clearly that gets you hired. Up next, we'll apply this same depth to platforms like Pinterest, Slack, and even rate limiting at Twitter scale. Let's keep going. Now let's shift gears and look at Pinterest, another platform that handles massive user-generated content with complex API interactions. Imagine a user browsing a board filled with pins, each pin tagged with categories like home decor, DIY crafts, or modern design. When the user searches within a board for specific tags, the backend needs to quickly return the most relevant pins. This is where query parameters, indexing, and access control come into play, and how Pinterest maintains speed and security at scale. How can you optimize tag-based search to improve performance at scale? Why it matters. With millions of pins and tags, Pinterest can't afford slow search performance. Users expect lightning-fast results filtered by tag, board, and popularity. Solution: use compound indexing. Let's look at an example using MongoDB. What's happening here? We are pre-indexing the fields most commonly used in search and sorting: board ID, tags, and popularity. This drastically reduces lookup time and improves performance on filtered queries. It's efficient, scalable, and essential when your data grows into the millions, just like Pinterest's. How do you enforce access control so users can only access their own boards? Why it matters. A Pinterest user should never be able to view or manipulate another user's private boards or pins. That's where access validation becomes critical. Solution: authorization check using JWT. Here's how we can secure the endpoint. We validate the token using middleware, then double check that the UID in the URL matches the authenticated user's ID. If not, the server immediately blocks the request with a 403 forbidden. This approach safeguards user data, prevents unauthorized access, and is a foundational practice in secure API development, especially for platforms with personal content like Pinterest. Here's the reality: the bar is higher now. Interviewers expect you to go beyond theory and show real world understanding, like how to structure performant index searches or enforce strict access control on dynamic endpoints. It's not just about coding, it's about solving problems at scale, like Pinterest does. Certifications help, but it's your ability to think deeply, build securely, and explain clearly that gets you hired. We've seen how Airbnb handles bookings and how Pinterest powers fast search. Now let's look at Slack, the real time messaging platform trusted by millions of teams worldwide. Slack isn't just a chat app, it's a real time communication engine where channels, messages, timestamps, and user interactions need to flow instantly and efficiently. Behind that experience lies precise API engineering with high speed querying and seamless push updates. Let's explore how Slack style systems use query parameters and smart backend strategies to deliver lightning fast, real time experiences. Imagine you're browsing a Slack channel and want to see only the messages sent by Alice after April 1st, 2024. The front end makes a request like this. This query needs to be filtered by channel, by sender, and by timestamp. And it has to be lightning fast, even if there are millions of messages in that channel. Let's explore two advanced backend questions built around this real world need. How would you implement efficient filtering of chat messages by sender and timestamp? Why it matters. When channels contain thousands, even millions of messages, simple queries won't scale. Users expect instant loading when they scroll or filter messages by time or user. Solution: compound indexing. Using a compound index in MongoDB or equivalent in SQL drastically reduces lookup time by combining multiple fields such as channel ID, sender, and sent at into one fast access index. Sample implementation: MongoDB. This approach ensures that even complex multi-condition queries return results almost instantly, exactly what Slack needs to keep conversations snappy and responsive. How can you support real-time updates for new messages in this endpoint? Why it matters. Slack is all about real-time collaboration. When someone sends a message, every participant in that channel should receive it instantly without refreshing or polling the server. Solution: WebSocket integration, Socket IO. By using WebSockets, the server can push new messages to clients in real time, ensuring users always stay in sync with the latest conversation flow. Sample implementation: Node.js plus Socket.io. This real time model allows seamless message delivery. No lag, no refresh, just smooth live updates across all users in a channel. As with Airbnb and Pinterest, what sets systems like Slack apart is smart engineering under the hood, not just UI magic. And in today's tech interviews, interviewers expect you to know that. From compound indexing for fast filtering to WebSocket integration for real time updates, these techniques show you're not just coding, you're building production grade systems. In this AI driven hiring landscape, it's not enough to say, I know WebSockets. You need to explain when, why, and how you'd use them with real world examples like Slack. All right, we've explored Slack's real time messaging and how to deliver blazing fast filtered responses. Now we're stepping into one of the most crucial challenges for any high scale platform: rate limiting, the technique that helps apps like Twitter survive millions of requests per second without crashing. Why does this matter? Because in real world API design, it's not enough to serve fast or secure responses. You also need to protect your system from overuse, abuse, and DDoS like floods. Rate limiting is your first line of defense. Let's break down how it works with two critical questions. How would you enforce rate limiting on this endpoint for each user? Why it matters. Imagine thousands of users refreshing timelines, sending tweets, or checking notifications every second. If each user is allowed to hammer the server endlessly, your infrastructure won't survive the load. Solution: token bucket algorithm. The token bucket strategy allows each user a certain number of tokens or requests within a time window. Requests are allowed as long as the user has tokens, allowing smooth bursts but capping total usage. Sample implementation: Express plus Redis. Token bucket ensures scalable fairness. Users can burst temporarily but are throttled if they exceed their allocated rate, protecting your API under real-time load. How do you ensure clients know their usage and when to retry after hitting the limit? Why it matters. If a client hits a rate limit without knowing how much they've used or when they can retry, it leads to bad user experience and wasted retry loops. Solution: send rate headers. Expose transparent rate limit metadata using HTTP headers, including the total limit, remaining requests, and reset timestamp, so the client knows how to behave next. Sample implementation: express header injection. Adding headers like X rate limit remaining and X rate limit reset lets the client self throttle, creating smarter, more respectful integrations. Exactly what high-scale APIs like Twitter demand. As we wrap up this video, let's step back and recognize what we've truly built here. High-scale API design isn't just about routes and responses. It's about thinking like a systems engineer. From Airbnb's query filtering to Pinterest's index tuning, Slack's real-time channels, and Twitter's rate limiting, you've seen how to design APIs that don't just work, they scale, protect, and empower user experiences at global scale. And in today's AI driven, performance heavy hiring landscape, basic answers won't cut it anymore. Interviewers want to hear your reasoning. They want real world readiness, implementation fluency, and deep architectural thinking. Training and certificates are good, but confidence, clarity, and practical application is what gets you hired. What's next? In the next video, we're taking it even further. We'll dive into more advanced interview questions, real world solutions, and best practices specifically focused on query parameters, how to structure them, optimize them, and defend against misuse, especially in high traffic production systems. So stay tuned. You're not just learning API theory here. You're preparing to build and explain production grade APIs like a true backend architect. Let's keep scaling.